Hello there. Today we're going to be answering the following question. And simply, find the missing measurement AC. Assume the line BD is perpendicular to AC and the line CE is perpendicular to AB. And I've drawn the corresponding picture here. So you notice that the triangle is from there to there to there, and they tell us that the base is this, we have a diagonal element, that is that, and we have the height of the triangle is 3.2 centimeters. So the way to go about solving questions with triangles is often by the use of the Pythagorean theorem. And in this triangle here, we do have some right angles because they tell us that BD is perpendicular to AC, so this part is perpendicular, so we got a right triangle here. So we could use that information, and that information along with the Pythagorean theorem would allow us to find this line here, because this would be our hypotenuse and this would be one of the sides, so we know 2 out of 3, so we could find the length of AC. However, that wouldn't tell us what we're looking for, because we're looking for DC. Okay, so if we found the length of AD, and if we found the length of CD, then we could just solve for the length of AC. However, in order to solve for the length of DC, we would need to know that one, that's a right triangle, and that is true because this is a 90-degree angle here, so this must be 90 degrees as well. And we know one side, but we don't know this side. If we knew this side, then we could use Pythagorean theorem a second time and find that side, but we don't. We do know this side, so that's some information. If we could use the length of this side to find the length of this side, then that would be great, and that would solve our problem. But we need to know the length of this part, and we don't. So we can't use the Pythagorean theorem in order to solve this problem. One other way we can solve this problem is through the use of area. So the area, and let's use blue. So the area of a triangle is 1/2 times the base, the length of the base, times the length of the height. So here we know, looking at this triangle here, that the area there has a base of 6 centimeters here, and it has a height of 3.2 centimeters. So we got that. So we could find the area of this triangle, but we're not trying to find the area. We're trying to find the length of this side. However, notice how we have this triangle here with the base of 6 and a height of 3.2 centimeters. However, we can redraw this triangle actually. And then so imagine if we rotate it counterclockwise until we have the following shape. So we're gonna have a base like that. And this won't be exactly to scale, but it'll get the idea across. If we had this line here. So notice how if we rotate it counterclockwise, we can get it into this orientation. And then from here, we have that height is 2.5 centimeters. And then we would know the area. So the area of this triangle would also be base times height. And conveniently, the base is AC, which is what we're looking for. So if we find the area from the original triangle, we can use that with the second triangle, or the new orientation, to solve for the length of the base, AC. So let's go ahead and do that. So here, on the left, I'm going to do 1/2 times the base, which is 6.00 centimeters, times the height, which is 3.2 2 centimeters. And if you do the multiplication here, well, that's 3.00 centimeters, 1/2 times 6, times 3.2 centimeters. Multiply 3 times 3.2, and you get 9.6 centimeters squared. So that's the area of the triangle. Doesn't matter the orientation, when the area of the triangle is the same area no matter what orientation. But now we have this second triangle, the area of the second triangle, which is also going to be 1/2 times the base times the height. There. Let's call it area 2, and let's go with area 1. So area of the first triangle was that, area of the second triangle. Well, the area of the second triangle is equal to the area of the first triangle, just in a different orientation, right? So let's fill in some numbers here. Well, we know the area of the first triangle was 9.6 centimeters squared. And the second part, well, the base is what we're looking for, and the base is the length of AC. The height we know, which is 2.5 centimeters. So if we arrange the math and we multiply both sides by 2, multiply that side by 2, and multiply this side by 2, those 2's will cancel. And if I divide the right-hand side and the left-hand side by 2.5 centimeters, well, that will cancel. So here we will be left with 2 times 9.6 centimeters squared over 2.5 centimeters, and that will equal the length AC. And if you throw that into a calculator, do the division, you'll find that out, that is equal to 7.68 centimeters. And notice how the units cancel out nicely. And that is how you find the length of that side. Originally when you look at questions like these, you think Pythagorean theorem, but sometimes you have to think about something else. And in this case, the other thing we had to think about was the area of a triangle.